300 meters below the ocean's surface. In a realm without sunlight or sound, a steel monster moves silently. It hasn't surfaced in 90 days, and it won't need to for many more. This is a nuclear submarine, a mobile fortress powered by a miniature nuclear power plant. It can travel across oceans, generate its own electricity, purify water from the sea, and produce oxygen from nothing more than water molecules. But how exactly does it survive under the ocean for months? And why has it become one of the most advanced machines ever engineered? To understand this marvel, we'll dive into nuclear propulsion, water chemistry, air recycling, stealth engineering, and even the psychology of surviving underwater isolation. Early submarines weren't truly submersible. They were diesel-electric hybrids, charging batteries on the surface, then diving with limited power. They had to surface every day for air. But in 1955, everything changed, with the launch of the USS Nautilus, the world's first nuclear-powered submarine. For the first time, a sub could cross the Atlantic, completely submerged. This innovation unlocked true stealth and endurance. Suddenly, submarines became invisible, not just in sight, but in endurance, strategy, and power. At the core of a nuclear submarine is a compact pressurized water reactor, fueled by enriched uranium. In controlled fission, uranium atoms split, releasing intense heat. This heat converts water into high-pressure steam. That steam spins turbines to generate electricity. The same turbines also drive the propellers. No oxygen needed, no smoke, just silent, efficient motion. And the fuel? A single uranium core can last over 20 years. Nuclear submarines don't need to refuel for decades. That means near infinite range, limited only by the humans on board. But motion isn't enough. Submarines must be livable. They need to generate breathable air, clean water, and regulate temperature and pressure. Nuclear power provides the energy to split water molecules via electrolysis, producing oxygen for the crew. Excess hydrogen is vented. Carbon dioxide from human breath is scrubbed out using chemical absorbers. The air is constantly recycled, just like in a spacecraft. As for water, it's pulled directly from the ocean. Heat from the reactor distills seawater, removing salt and creating hundreds of gallons of drinkable water every day. These systems allow submarines to stay submerged, not for days, but for months. Over 130 sailors live inside this steel vessel. Privacy doesn't exist. Bunks are shared in shifts. Noise is constant. Time is blurred. The crew rotate on 6-hour watches. Lights never fully turn off. Fresh food runs out after a few weeks, leaving mostly processed meals. The psychological burden is immense. No sunlight, no family calls, no escape. Missions last up to 90 days, but some strategic patrols stretch even longer. Mental endurance becomes as important as engineering. Submariners are selected and trained. For resilience, it's not the reactor that limits a submarine. It's the human mind. One of the most critical systems isn't visible, it's silence. Submarines are designed to vanish from sonar. Everything on board, from pumps to pipes, is isolated to prevent vibrations. Outer hulls are coated in rubberized acoustic tiles that absorb sound. In hostile waters, submarines enter silent running. They float silently, listening to everything, while saying nothing. Despite its power, a nuclear submarine cannot stay underwater forever. Food supplies dwindle, mental health deteriorates, and mechanical parts wear down. Most submarines surface after 70 to 90 days, but in wartime, some have stayed submerged for over 120 days, breaking records in silence. When they surface, it's not for fuel, but for food and for sanity. What began as a military innovation could soon shape our future. The closed-loop systems in nuclear submarines are being studied for long-term space missions, deep-sea habitats, and even disaster-proof bunkers. The same technologies that allow submariners to survive without surfacing could one day keep astronauts alive on Mars or researchers stationed in the Arctic. In a world facing climate instability and resource challenges, submarine engineering may become the blueprint for human survival in extreme environments. A nuclear submarine isn't just a machine. It's a self-contained ecosystem, a floating power plant, a survival chamber, a symbol of what's possible when engineering meets endurance.
Thanks for exploring. If you learned something new today, like, subscribe, and share this with fellow innovators. Have a question about how submarines work or another invention you want explained? Drop it in the comments.